Yes.
I'm Jason. I'm a rising senior at Middlebury College. And I was just wondering if you could briefly opine on the recent successful anti-ballistic missile test on Sunday, and the concerns about it not, the lack of consistency in the amount of spending that the defense is spending on, planning to spend $1 billion to construct 14 more of them in the next 3 years. Do you have anything to say about it? Any additional information? I'm curious.
Well, I don't have any additional information. A lot of these questions, and I should probably, maybe I didn't preface it enough, but as a technology laboratory, our goal is to help implement policy, not to decide policy. So questions of things like missile defense, it's really a policy issue, and it's something between the administration, Congress, and others that fund the Defense Department that fund these things. So, our role would come into that and looking at the implications of it. How to, in some cases, we support some of these missions because it's an assignment that we get from the government. But I don't have really an opinion on the merits of it or the spending of it. That's a political decision.
Okay.
Sorry for
no.
That's really the truth of it.
Yeah.
Yes.
Hey, Matt Oldham from the University of Georgia. My question is more related to what Sandia has done as far as cybersecurity for these countries, so different programs you guys have maybe looked into for developing stronger cybersecurity systems.
Mm-hmm. To be honest, most of the cyber work we've been doing up to date has been domestic focused. We're right on the cusp of really trying to decide what that means internationally. It's a very evolving subject, and in fact, we have a group we're working with some other colleagues here from Monterey, I think, to try to bring a group here later this summer to explore some of that. So we don't have much of a track record internationally on cyber. It's sort of the newest element of all of this, but I think it's going to be critical to it because we've always worried about cyber from the standpoint of data authentication and so forth, and that's always been an element of treaty systems and others that we've had, because you want to know if you're getting information from a sensor that it's truly the information that started at the sensor, that hasn't been intercepted and so forth. And there are a number of well-established techniques for doing private and public key authentication and encryption and so forth, and those have been used for a long time. But the broader look at cyber and what it means, both as a weapon and as a defensive tool and as a design tool, that's more evolving, and so we really haven't done a lot with that internationally yet. So, but I expect it will start to increase because it's a subject that's getting a lot more attention and funding now. So,
thank you.
Yes.
Yes, thank you. Very interesting, and I was very intrigued by one of the activities you mentioned, especially the upcoming workshop. You mentioned you're dealing with the root cause analysis and personnel security program. And who are the target audience? And these are mainly focusing on some nuclear power plant worker or more broader audience. And if you could provide a little bit more information, it's a very interesting concept. So.
Sure. It has applicability to all kinds of issues. I think initially we're going to look at it from a nuclear power plant operator standpoint, and so we'll be presenting it to audiences of people that work in the nuclear power industry initially. But I think a lot of the concepts and ideas that are developed could be targeted to a different kind of an audience if you had interest. So if you're interested, I could take your information and or talk with you afterwards about specific areas where you think it might be of interest, and we could explore whether there be opportunities there.
Right, thank you.
Okay,
So this is international type audience?
Internationally, it's designed to be international, yes. Mm-hmm. Yeah, Feroz.
Yeah, I'm Feroz Khan, Naval Postgraduate School. Kent, my question pertains to that mobile radiation detection thing that you showed.
Right.
In that. Now, two questions with that. Is that technology shareable with other countries? So, and the second one is that what is the spectrum of detection of that software?
Mhm.
Because if it is out of higher spectrum, then pilferage of radiological material in containers or trucks or other places that it was shown, it looks like more like placed on a bridge or a G5 or someplace, either across a facility or even transportation on the road or bridges. So you can detect immediately if anything is going. But if the spectrum is very low, then low level of radioactive sources can still pass through that system. Has that been thought through? I say this because I think I recall that this was an issue that came across in one of the nuclear security debates that I participated in. And my understanding was that this software technology is still classified and cannot be shared with other countries. So do you have any information on that?
Well, the MERDIS system that I showed has actually been deployed in other countries as part of the second line of defense, the Megaports project. So they've actually deployed these in foreign ports. And part of the goal is to detect these things wherever you can in the world. And so I personally just am not the expert on the spectrum that it measures. I do know that, measuring radiation signatures, there are a lot of factors that go into that. One of them that's critical is the time. How long do you have to do a count? Another is how much shielding is there, whether it's deliberate shielding or whether it's just shielding as a result of other cargo that's surrounding the device in the container. And on these systems, some of them are attached to the actual hoists and cranes that are lifting and moving things on and off of ships, and so that gives you added dwell time. Is this a perfect system? I say no. I think there have been I know there have been system analyses. I don't know the results of them exactly that say, how much can you get by with or that sort of thing. And I just don't know the answer to that. But it's a complicated systems analysis depending on the material, the amount of material, the amount of shielding, the amount of dwell time. There's a lot of factors that go into it. But I think the goal is that you would detect significant quantities of materials. Whether you detect all materials, I don't know. But I could try to see if I can find a report or something to forward to you on that. I don't know the details. Yes.
And Nida, I just wanted to ask that is SNL doing anything in terms of with regards to nuclear forensics? Because it's sort of an upcoming field and it's technology related, so I was just wondering.
Yes. There's a staff member in my organization that has a PhD in that subject, and he's working right now to try to develop some computer codes that would help him calculate back. Let's say you find a spent fuel rod, and you want to know where that might have come from or what the operating history of that is. So he's trying right now, it's a research project, to develop codes that would allow you to sort of calculate backwards, because there are codes that allow you to start with a known distribution of nuclear fuel and then put it in certain kind of operating conditions in a particular type of reactor and then calculate what the end result is. And he's trying to essentially work that backwards. If you find the fuel, could you calculate back? There might be more than one way to get back. So we are doing that kind of research work.
But is it like really just domestic right now? Because I don't think the international countries from around the world they share their nuclear signatures?
No,
They don't.
but there's an effort underway, or at least there's discussions internationally on the idea of establishing what they call nuclear fuel libraries, which would be databases of information about the characteristics of nuclear fuel in different countries in different reactors. And then, of course, reactors can be operated under different parameters, for the amount of where in the core the fuel is, how long it's in the core, how much power it's operated under, and all of that can impact the eventual production of the spent fuel products. But I think there are debates and there have been meetings and conferences held to discuss the idea of libraries of fuel, but I think people have not agreed on that yet. That would take a lot of cooperation internationally to do that, but it might be useful eventually to have something like that to help establish the forensics and the history and origins of materials. Mm-hmm. Yes.
Hi, my name is Jovisa. I'm from Hong Kong. I'm currently an undergrad at Monterey College, and I'm a geology major.
Okay.
And so a while ago you mentioned that the national laboratories here, they help implement policies, but they cannot decide on policies. And so I was wondering what happened in Sandia when funding for the Yucca Mountain Geological Depository was cut, and like how does that affect the lives of scientists and engineers there? And maybe in a general sense, if you cannot speak about this specific issue, but also, but if you can about this specific issue, I was wondering what is the current situation and the future for research on developing geological depositories for nuclear waste management.
Yeah, very good question. You had a lot of good subparts of your question there. As far as the impact on people, it was very impactful on Sandia, because Sandia hired a lot of people, did a lot of work to get the licensing application done. In fact, they turned to Sandia. There was a lot of delays and problems in getting the licensing for that developed, and Sandia got the licensing approved through a lot of work, including a lot of geological work for the Yucca Mountain Repository. And then for political reasons, the state of Nevada, particularly Senator Reed, just killed the funding for it and just said it will not happen. And so a number of people were displaced. I think many people had to leave the lab, other people had to relocate to find other jobs in the lab. Sandia had a large office in Nevada in support of that project, and that was closed. And so the people that either lost their jobs or they had to relocate or they had to do other kind of work. So it was very impactful when you are supporting any kind of a program and then it gets cut off like that. So that was a big impact. But it's a political decision. We go with the decisions of politicians, and then we have to just adjust to that and move on to whatever the next priority is for the country. But that does leave the country with a lack of long-term solutions to our nuclear waste disposal. And in fact, it's costing the Department of Energy billions of dollars a year in fines, because for many years the power companies have been taxed for eventual disposal by the government of their nuclear waste. And now that in the deal we promised to have a site in place to take that, and now we don't. And so they have to pay money back to the utilities every year to make up for that. And the utilities have to store their waste spent fuel on site at all of the various power plants all over the country. So it leaves open the question of what do we do next? There are clearly answers for geological disposal, but it requires political approval. So you've got to find a geographic region where the people and the politicians and everybody and the geology are suitable for doing that. And right now that solution was thought to be Nevada, but it's proven not to be Nevada. Some other ideas that have been explored and are being explored from a research standpoint, one of them is what's called deep borehole disposal. And it's the idea of vitrifying nuclear waste into sort of glass blocks or pellets, and then drilling very deep, miles deep kinds of drill holes, and then depositing those way down in the Earth's crust, and then covering it up. So that's something that's being explored, but politically I just don't know. I think that's still a combination of research and the political uncertainty. You've still got to find somebody that's willing to let you do it in their location. So that remains the big problem, I think, for nuclear power going forward, is what do we do with the waste, because we don't have good solutions for that.
And a follow-up question, if there hasn't been like a final depository site being decided, or it cannot be it cannot be foreseen if this will be developed in the near future. Do you think there will be the U.S. will open up or continue developing technology for reprocessing, which would have non-proliferation implications and
Yeah, that's a very good question, and that really comes down again to a political decision. You know, our country made a decision a long time ago to not go that way, mostly in support of our non-proliferation objectives, to not encourage the production of plutonium and things from spent fuel. And so that was a political decision. Whether that would change, now that could partially solve the waste problem, but it doesn't completely solve the waste problem, because even with reprocessing, there's still very highly radioactive waste product. There's less of it. You still have a problem of having to have some place to put that as well. So I think time will tell, and your generations will probably be the ones making a lot of these decisions about what direction the country is going to be taking with respect to nuclear power in general. And of course, there's research work on complete alternative approaches to nuclear energy too, particularly fusion energy, which if that could be successfully harnessed, that's a completely different problem, and you don't have the different kinds of waste products that we worry about in the conventional nuclear fuel cycle. So I don't have good answers for you, because this is really in the realm of the political dialogue that will go on in the years to come, I think. Yes?
So I just want to say, I have a question. I also want to say that actually Sandia is really making a lot of progress on the deep borehole disposal.
Mm-hmm.
They're really the ones who are pushing and doing a lot of the research.
Right.
Just really impressive. You mentioned, not by name, but you mentioned information barriers. What sort of research is ongoing now in information barriers, and with other countries maybe? So with China instead of, US and Russia, with other countries.
Yeah, it's not the area I'm most familiar with, so I know there's research going on trying to understand it and figure out how those information barriers would be developed. I don't think there's much in terms of, I'm not aware of much international work now. I know there's been early on there was some US-Russia dialogue about it. I don't know if we've actually deployed anything experimentally. A number of years ago, probably a dozen years ago or more, there were some experiments to start looking at this greater level of transparency with respect to weapons with the Russians, but it was not actually with real nuclear material or anything. But it was like a simulated bunker at Sandia and a simulated bunker in Russia, and there would be cameras and instrumentation and things placed there, and we would observe each other's through a real-time data link. But in terms of information barrier projects, I'm not aware of international. There may be some, I just am not the person working that, so I don't know. I could certainly find out and try to let you know if I can. But beyond Russia, I don't know of any that exists. I'm not even sure we have anything active with Russia, but if we did, that would be probably where it is. Okay. Sorry, I don't know the answer.
No, that's okay. And also one more question, if I may.
Sure.
It's fascinating the work that you're doing, that Sandia is doing on sort of standardizing spectra and gamma spectra, for example. What sort of progress has been made in this? I've never heard. So will this apply, for example, to if you have an accident? Will this be standardization for nuclear power plants? After an accident. Is that what the idea is?
Are you talking about the forensics?
No, not much forensics. As I think you talked about sort of standardization of. I guess it's more forensic. No, it's not quite forensics. Of gamma analysis, of detector analysis. So, for example, I think you were mentioning different countries where you want to make sure that the standardization of when you're looking at something will be the same for different countries.
Yeah, okay. I think I was referring to what we call the RMCC program, the Radiation Monitoring Cross Calibration. Yeah, the DOE has a program that they use with domestic laboratories in which they have these calibrated samples of various radioactive materials that they send out as a way, places like Sandia and other labs, and as a way to sort of calibrate their own measurement expertise and facilities. And so what we've done is just taken that model, and we got approval to apply it internationally. So DOE is able to send these samples to the partner countries of this program, and then they're able to do the same thing. They do their own assessment of the spectrum that they get, and then they come together and compare it with the known standard and try to understand deviations and so forth, and they share lessons learned about how they operate their laboratories.
So it's a common procedure, sample preparation,
Right.
that stuff too, right?
So it's analysis, preparation, procedures, it's all of the above. Right.
But it's really looking at after an accident has happened.
Well, it's really looking at calibrating, I guess so, yeah, I mean, it could be that, or it could just be any time they're going to be measuring some radiation signature from whatever the source, how reliable do you think their measurement is? And if they've been through a program like this, hopefully then you have kind of a common standard that's as though you measured it yourself. That's the goal.
Because this was a big issue with Fukushima, for example.
Right.
Yeah. Okay.
Right.
Very good.
Yes.
Hi, my name is Tuan. I'm a rising sophomore at Stanford.
Mm-hmm.
My question is with regards to South Asia. I was wondering if you could talk a bit about future challenges or issues facing nuclear security in that region, perhaps with regards to reprocessing or just issues specific to that region.
Well, obviously there's a lot of issues with respect to nuclear, including there's obviously with both India and Pakistan as possessors of nuclear weapons, as both countries with large nuclear power programs as well, and nuclear research programs. So they have research reactors, power reactors, defense reactors. So it's a very complex dynamic there. And of course they're outside the NPT itself. While they're adherents to a number of the non-proliferation related regimes, they are not part of the fundamental non-proliferation treaty, which presents fundamental challenges because they're among the countries most challenged because they're outside that realm. And so the way in which we can work with them is more limited. Of course, the U.S. did sign a nuclear agreement with India, but I'm not sure that has really developed very much in the way either expected, I think. In terms of nuclear security, we've, as I said, with this ITC course with the IAEA for 30 years, we've been working with, including India and Pakistan, on nuclear security of civilian power. I think the challenges remain of adequate controls within the countries. The challenges remain with the growth. As you get more and more people, particularly as you start to grow the number of nuclear power plants, you've got a lot more infrastructure, a lot more people handling it. So the ability to keep track of all of that and to make sure everybody is on the same page. Sometimes when you have a small cadre of people, it's easier to control information, it's easier to control people. And when you start getting thousands of people, it's a much bigger challenge. So I think, but I think both countries are committed to doing so responsibly. That's just a matter of working to build their capacity to do adequate safety, security, and safeguards in both countries. I don't know, maybe one of my South Asian colleagues here would want to add anything, but. Yes, sure.
Question. Recently there was an issue of aging workforce in the national labs, in the nuclear sector. Is it something that is relevant to Sandia? And what does Sandia do to attract new specialists? Are there internships? And I think for our group of young, bright students here, maybe there is some information that you could share.
Sure.
There are opportunities for them to pursue. I hope they will stay in the field, especially after your presentation.
Sure.
And if there are some efforts Sandia currently has to attract new specialists.
Sure. Sandia has a very active student program. I think every summer there's probably, it's in the order of hundreds, 500 to 800 summer students that come on from all over the country. Historically, Sandia only hired American citizens, but now we actually have provision to hire some foreign nationals for some parts of the work of Sandia. But we do have an active internship program, and the Sandia website, sandia.gov, has links to career opportunities, including for students. So there are internships that exist for both summer students and for year-round students, both. There's also programs within the Department of Energy. They have a Non-Proliferation Fellows program that they hire recent graduates that work for their agency, and then sometimes they get opportunities to serve in other agencies of government as part of their fellowship program. And then we've actually hired a few of the folks out of that program into our program. As I say, primarily Sandia hires technical-based people, chemists, scientists, engineers, and so forth. Although we do have a smaller set of social scientists as well, international relations, political science. So there are some opportunities that 20 years ago there really weren't those opportunities at the national labs, but there are now. So we have both long-term and short-term career opportunities for students, and probably the best thing to do would be to at least get familiar with that on the website, and then if you're interested, we could pursue it further and send me a resume or something. I'd be glad to circulate that, see what the opportunities might be. And of course, every year it varies based on the funding cycles, and I'm sure as you find out here, we're all sort of, because we're primarily a government-funded laboratory, we're subject to the whims of the budget cycle or the indecisions in Congress to pass a budget and things, which causes some uncertainties in our hiring profile. But the lab has stayed pretty, solid over the years. There's always threats of big delays, and any particular program can be cut off, as we talked about with the waste repositories at any time. But collectively, the lab is very versatile and flexible and moving. So we're half the work that we do now isn't work we were doing 10 or 12 years ago, because it's evolved. It's new missions, it's new challenges, new technologies, and so we're constantly reinventing ourselves every few years.
Yeah, I think on this note we'll
Okay.
conclude. I would like to